You people who sat down close, you're going to be in the best shape because you get to see it all live as it happens. I want to thank you all for coming to visit Professor Andy David. He's a retired professor emeritus at Rochester Institute of Technology, chairman of the imaging department. He's done some things with cameras that you would not believe. And things that he does aren't things that are pre-programmed. You just have to press play to get him to do. There's problem solving involved, there's experience, there's knowledge, and some of it's really interesting. So I think you're going to find it interesting. If you are entertained by what happens this afternoon, I'd like you to come in this evening. There's a 7 o'clock show as well. It'll be an entirely different batch of stuff. And now I'd like you to give a quick welcome to Mr. Andy David Hazy, and we'll get things started.
First of all, wow, this is the biggest audience I've had. Usually I do these presentations in classrooms, not in auditorium. So I hope you bear with me, those of you who are kind of far away. We'll hopefully manage to do this. Anyway, I'm associated with photography in one way or another. You're finding on it, you surf the web, you're finding quite rarely. But besides that, photography has been my life, but in a slightly different way than you probably think photography is all about. So I have a couple of photographs to start the presentation discussion and the thinking about what it is that I'm all about. I presume that you all have photographed flowers, haven't you?
Yes.
I'm not about photographing flowers. You probably know landscapes too, right? Yes. I'm not about that. When you think about photography, that's the thing that most people think about. Or, another landscape. I've traveled to wherever and I photographed this mountain. Great. I don't do that. Or you might do architectural photography. A lot of people who earn a respectable living, very successful in making pictures of buildings and interiors. Another auditorium from the outside. I don't do it. Now, there are some times that a situation becomes more challenging than simply snapping a shutter. For example, in this case, somebody, a friend of mine, photographed the shuttle taking off. Well, that's not the shuttle frozen in time, but it's the track of the shuttle engine as it streaked through the sky. Again, this is now calls for a little thinking. You don't just snap a picture. One want to photograph action, like, for example, this young lady jumping. A cheerleader jumping. Yeah, except she's in two places in the same photograph. And there's a blur in between. So your mind says, oh yeah, these two are connected, and this is how she moves. And this is more exciting, I think, than a still photograph of this cheerleader. But how do you do this? You don't just snap a picture. You don't say, oh, camera, do this. You might do this in Photoshop. Some of you I saw are working with it. But it's a lot easier sometimes to just capture for real at the beginning. Or you might be photographing in a hostile environment. And hostile doesn't have to be real hostile. You're in the water. Okay? You don't just take any old camera down there and start photographing. You got to take some thinking about what are you going to do to make photographs there. Or things might be invisible or hard to see because they're too far away. Well, an eclipse is such a situation. And it's hard to, you don't want to look at these, but you want to make a photograph of it to show the corona. Well, or in another astronomy application, you might want to photograph a comet. There are 3 of these up in the sky now. I haven't seen any one of them, and I froze. I froze. I had 3 nights in a row trying to see one. But you want to photograph a comet, you want to photograph a constellation, star, and so on. Actually, the truth is that astronomers are really nothing more than photographers. No self-respecting astronomer actually puts the eye behind the eyepiece and looks at the sky. They don't do that. It's a waste of time. What they do is they make pictures. And then they look at the pictures. Well, if they make pictures, aren't they photographers? They are. But they have an additional bit of knowledge about the universe. So I call astronomers glorified photographers. They don't like me to say that. It's just my little way of poking fun at them. Now, there are situations where you might want to create something which is really real. Now, you can do things like this, whatever this is, in Photoshop. However, the truth is you cannot do this in Photoshop. You might do something that looks like it, but this is a photograph that involves time in the making of the photograph. This is what might be called a special effect. I'm not sure what the purpose was. Here you have a floor buffer chasing this guy, but that's sort of beside the point. Here, there's a picture of somebody being stretched. Well, they're really stretched or what? I don't know. Or here's a couple that exchange positions between the making of the photograph. And hopefully we'll have time to do some of this. Now you might want to get involved in action photography. Well, telescopic photography is one way to do that. And there'll be a bunch of demonstrations of telescopic photography this evening. But if you want to demonstrate action, you want to follow action, you can do it with a movie camera, or you can make a still shot. But making a lot of still shots gives you a possibility of tracking the motion of an active, for example. Making photographs of temperature, heat, is another occupation that some photographers get involved with. They're not landscape photographers and so on. But how do you make photographs of the heat coming off these candle flames? You know that they're hot because you put your hand on top and you can feel the heat. So how do you make a photograph of that heat rising from the candle flame? Well, it's not as simple as just snapping a picture. You got to know some physics in the background. Polarization is another application that many scientists and so on get involved with to show stress patterns in crystalline materials like plastics and so on. Again, on the area of special effects, you might want to make a photograph of somebody's head that goes all the way around the head. Like this one. So you can make a picture of the skull looking from one point of view, or from another point of view, but this one shows you the skull all the way around. How do you do that? My specialty, sort of interest for a long time, however, has been high-speed photography. And kind of the cliche photograph is a bullet in flight, in this case interacting with a banana. You got to think about, well, how do I do something like that? Why would I want to do that? I don't know. But if you know how to do something like this, you can apply it in many other situations. So, a bullet going through a light bulb. A bullet cutting some rubber bands. A cut over here and a cut over there so the rubber band is spreading apart. Make a V shape in the rubber band because there's elapsed time there. What's this? There are people like this one. Tomatoes being shot by bullets. Or a jolt can. This is an old jolt can being shot up by a bullet too. So these are just illustrations of what's possible from a very lighthearted point of view. There are not too many applications, I must admit, where you want to photograph a bullet going through a tomato. Who cares? But if you know how to do that, in that case you can apply it again, as I said, in many other situations. This photograph of a bullet in its shot row, a V-shaped thing here, that's what the sound is when a supersonic plane flies overhead and you get a bang on your ears, that's the edge of that shot. And here it's visualized, and you can see the bullet. And from this you can tell something about the bullet, how fast it's moving, for example, and what kind of turbulence it has. People in bullet manufacturing are interested in stuff like that. Now this is a bee in free flight. You're going to take my word for it. It's a bee in free flight. It's a live bee. I didn't just catch it and kill it and put it there. This is probably the hardest photograph. Among all the ones I've shown you, this is the hardest one to make. You can't just go around chasing a bee with your camera. It's kind of funky. And the bee, or the wasp, you know, they might get angry too if you're trying to chase it. That's no good. So you have to think about, well, not only how do I make the photograph, because the wasp is in different places all the time, how do I make the wasp go to one spot where I have the camera aimed? You got to think about that. And then when you make a picture, how do you do that? Take some thinking, some insight into the problems associated with it. Now, the reason that I say it's the hardest picture that I've shown you is because not only do you have to know something about photography, you have to know something about wasps, what they do, how they do it, how they behave, and so on. And so this is by way of introduction. And now, as Jim said, I'm going to do some problem solving with photography, kind of sort of related to what you just saw. So we're going to make photographs. Now, some of you, I'm sure, have cameras that are even better than this one. This is a very basic, very early model of a digital camera. So we're going to make photographs. And you're going to see them on the screen as you make them. And what are we going to photograph? Well, has it been raining here recently? Yeah, some time ago, right? Have you ever looked at the rain drops fall on the ground and you see something happen there? It doesn't last very long, does it? You kind of sort of know what it looks like. But if I were to say, well, describe accurately what it looks like, I can't do it. It happens too quickly. So we're going to photograph splashes. But instead of water, what I propose we do is we photograph milk, which is a little easier to see. All right, so we've got our experiment going. Put some milk in here. Well, you know what I could use? Probably some paper towels. Okay. And we need an impact zone, so put something in here. Now, not that it makes much difference, but this is the first time that in a demonstration setting I've done this. So you're kind of privileged and I'm kind of nervous. So we're going to make some drops come down here. Okay, and now we're going to make those drops hit something. So we're going to put this over here. And it's making a little something go there very quickly. Okay. We want to photograph it. How do we do it? Well, stop that for a minute. I'm trying to make a photograph of those drops. I'll take the camera, put it over here. And trying to make a photograph of those drops is kind of hard. Why? Yeah, you don't know exactly when it's going to happen, and you're going to push this button. You're going to be late all the time. Not only that, it happens very quickly. Those things are moving very fast. So we need to look at them for a very short time. And it's a good thing I forgot about it. To do with is looking at something for a short time. The camera can't do that. You may have cameras that have a shutter speed that lets you blink in a thousandth of a second, or a 4,000th of a second. These things move way too fast for that. If you photograph them with that, pictures are going to be blurry. We don't want blurry photographs. Right? Those are easy to make. How many can make blurry photographs? Yeah, there you go. Those are easy to make. We want to make sharp ones. Well, the shutter speed on the camera is not short enough to capture sharp pictures of these very fast-moving events. So what we're going to do instead is use a device that gives us such short exposure times, and that is an electronic flash. Like that one. However, others are just as useful. When this makes a flash, like that, the duration of that is about a sorry about that. It's a 20,000th of a second. That's very short. In a 20,000th of a second, not too many things move very far. So we could imagine we're going to fire this flash at the time that the drop hits. Well, if I ask one of you to, kind of be over here, push the button when it hits, you're not going to catch it, right? So we need some means of making the flash happen when the drop is hitting. Well, this is a matter of synchronization, timing, and detecting when something should happen. Well, in this case, this falling drop doesn't make a sound, so we can't fire the flash because it makes sound, but it travels in space. So we can use something like a flashlight. Not what we're going to use, but we could do this. And when the drop moves in front of the flashlight, it causes the light to go out. Well, we can detect that. We can look at this flashlight with something and say, the light is on, the light is on, the light is on, the light is on, the light is off. And when it's off, we make the flash fire. A little bit of electronics goes a long way. So if you're ever thinking about having some kind of a side interest, look at electronics. It'll help you in a lot of ways, as will photography. I'm not here to convince anybody to become a photographer, but I am here to convince everybody that photography can be a useful tool no matter what you do. So I have here a device which mimics what I just did with flashlight. This red light, LED, looks into a detector that sees is there light or isn't there. And when there isn't light, it tells this box to fire the flash. All goes well. There. Line everything up. So this is the gadget that detects the light and causes the flash to fire. Let's see. So now the flash fires when I break the beam. We don't want to make a photograph when the drop is right there. Yeah, it's kind of an awkward. We want it when it's here, right? Yeah. So we need to introduce some delay. And say, okay, well, don't do it immediately. Do it a little later. How much later? Well, however long it takes the drop to go down to there. And when that happens, and the flash will go off, and we can make a photograph if the camera shutter is open at the time, because it makes no use for us to fire that and have this shutter closed. But what happens if you open the camera shutter? The camera starts to make a picture. Right? So in order to not to do that, and only make the photograph by the light of that flash, we need to do this in semi-darkness. And maybe I can get some help to kind of.
Do you want the LCD projector on?
Oh, yeah. You want to see? Yes. Yeah, I can. So it kind of seems to work.
Video info?
It's okay. Yeah, it'll be okay. I haven't taken a photograph, so.
Okay. And you let me know when you want to do it.
Yeah. You just need something to focus on.
Does anybody get really nervous when it's completely pitch black out?
It doesn't have to be total.
Okay, come on, you're going to come
It
with me.
doesn't have to be
Hold my
totally
hand.
Watch out, right? Okay, we're almost ready to start making photographs. If we okay, we could dim the lights a little bit. That's good. You can go down a little bit more if you can. Now notice where the drop is. You see it?
Yes.
Where is it? Right there. You saw it? Okay, well, we don't want it there. We want it further down, right? Okay? Awesome. So now what we're going to do is add a little delay. And the drop should be lower. Yeah, not yet. It's lower, right?
Yes.
It's after the splash.
I'm not sure we're getting. Oh, this.
There's a flash. Now it's a little bit too light, right? And so that means that we can do a little correction here.
Nice.
get the lights back up? Is that all right? And because we wanted to see what a rainbow actually looks like. What's happening in the wild, so to speak, is not that easy. So you want to get control of the situation. And then actually making a photograph is pretty easy. You just push the button, wait for the flash to happen, and there it is. But if you didn't previously know what the problems are and how to solve them, you'd be behind the eight ball, as some people say. So let's see if I can set something else up. By the way, if you have any questions or comments, yeah, it's quite welcome. How much time do we have? 13 minutes. Wow.
Goes fast, doesn't it?
Really fast. Okay. What am I going to do? I'm more inclined to deal with physics than I was with chemistry at the time. So, for those of you who are discouraged about any of these things, I'll tell you my story about physics. We used to be in a semester system, or we were in a semester system in school. It took me 6 semesters to go through 3 semesters. That means actually I have to work them all. It means I failed every semester at least once. And one of them I failed twice. I became friends with every teacher in the chemistry department. That was the good part. The chemistry is good. Physics, the good thing about it is it's like mechanical engineering. You can see things. And that's what I like. And that's sort of the byproduct of what you're seeing here. Yeah, any chemistry instructors? No. Well, chemistry is still good for you. Okay. Now, that demo, as I said, it was the first time that it's been done in a situation like this. What I'd like to do now is to try something which I haven't, again, done in this camera study. So this camera, or any camera for that matter, makes what you might call a snapshot. Holding time is kind of short, it might be 60 to a second, 1 second, it might be longer. But what it does, it photographs the whole scene all at once. Because sometimes you can make photographs that include time as an element in the making of the picture. Not as, the last 1 second or 2 seconds, but for time itself is a factor, is something that you can afterwards analyze, either for physics purposes or you can do it with a special effect. So what I'd like to do is to do it as a special effect this time. And let's see. I'm going to need some help. Great. Okay, let's be over here. And you just get over here for a second. What's your name? Danny? Yeah, actually maybe away from the black a little bit since we have the capability to do that. Okay. Yeah, we have a light on. Now notice I have this box in front of the camera lens. And the front of it is colored up. If I were to make a picture right now, what do you think the picture would look like? All black. However, in here, there is a mask that has a slot in it. If I were to make a picture not like right now, what would it look like? A very thin line, right? However, I have the capability of moving it. Now, let's see what we can do with that. Actually, maybe instead of moving up and down. And choose time this time instead of these. Well, this is again, I think in an experiment, when you're conducting experiments, sometimes you don't know what the right thing to do is. And you could be hampered by saying, well, I don't know what the right thing to do is, so I won't do anything. Well, that's kind of wasteful, isn't it? The thing to do is do something. And then you learn from it. Just like we did with the milk rock photograph. The first thing was way too white, right? Oh, okay, I can fix that. Make it darker. But if you don't do anything, nothing will happen. It's the same thing as, I don't want to encourage anybody that went to the lottery because that's kind of a waste of time. But if you don't enter, nothing happens. Publishing, writing, if you don't enter a contest, if you don't submit your work to be critiqued, evaluated, or paid for, it's not going to happen. The likelihood of somebody finding you hiding in a closet is pretty slim. So, again, I don't know totally exactly what's going to happen here, but we're going to give it a shot. So I'm making a photograph right now, and the slot is way at the bottom of the box. And the expectation is that we get a black picture. That's just what we expected. So this time, just kind of aim at you. What I'd like you to do is when you get a click of the shutter, you can start rotating. Okay? Slowly. Give me a sample of how fast you're going to go. That's very good. It's got the right speed. Go. Okay. Now, I didn't get too far. Now you start to see the beginnings of what's happening, right? Improve on this. And probably you can spin a little faster. Okay, you're going to spin a little faster, right? Okay. That's going to be inside. With a little less light, we can kind of see what happens. So, kind of high. faster. Okay. Oops. Never mind. I made a mistake.
Bring your sunglasses.
Okay. So when you hear the click, you can start moving. Oh, come on. Activated something I wasn't going to. Very good. You did it well. Stay there, but we're not getting anything. Right. Very good. You're very good at that. Nothing yet. Okay, we're going to try it again. There we go. It's starting to look like a corkscrew, right? Now, why is that? That's because the bottom of the feet were exposed before the top of the table. And in the time between the camera saw his feet and the time it saw his head, he had turned around. Well, try to do that with a regular camera. Can't do that. Try to do it in Photoshop. You can't do it either. And the reason you can't do it in Photoshop is because this photograph, this one, has information from his back as well as from his front. In Photoshop, you take a photograph and you spin it around. Well, you don't know what's on the back side. But here you do. This is a scanning process. Okay. You can sit down.
Thanks, Danny.
Thank you very much.